Okay, we've heard today a tricky looking problem. This one's from the Florida Integration Bee 2017, problem number 5. We have the integral of e to the sine x times sine e sine x plus sine e sine x minus x dx. Okay, at first I thought this one was harder than it actually is. I was trying to do something complicated and like distribute this in, maybe trying to see if I needed to do integration by parts or reverse product rule. And then the thing I realized is really this right here. I think all this can be simplified just using trig identities. Maybe to save ourselves some writing, let's kind of put some labels on things. If I call this A and I call this B, then what we really have here is we have sine A plus B plus sine A minus B. And then what you can do is expand this out using each of these formulas and you get cancellation. But I think there's maybe an easier way. If I just multiply this by 1/2, this is going to be the same thing as our formula for just sine A cos B. But if I multiply by 1/2, I'm changing it. So I don't want to change it. So let's multiply by a 2 on both sides. So now I'm just multiplying by 1 here, and we'll multiply by a 2 over here. So what that means is I can take everything we have right here and write it like this. So let's see what happens when we do that with our integral. We still have our e sine x up front, this part. But then all this here is going to reduce down to 2 sine of our a value, which is e sine x, times cosine of b, which is just cosine of x. But now with that simplification, we're actually in good shape for a u substitution. We don't want something crazy inside the sine function, right? So if I do my u substitution for this, just set u equal to e sine of x, take a derivative. So for our du value, we get back the same thing, e sine x, but then we need chain rule. Derivative on that is going to be cosine x dx. But then we have this du already in our expression. We have the e sine x here, cos x dx. So when we go ahead and substitute, let's bring the 2 up front of the integral. So this is going to be a 2 here. This becomes sine u, and everything else is just du. So I go ahead and integrate this. Integral of sine u is going to be minus cosine u, so we'll write it as minus 2 cosine u. Just back substitute in order to finish it off. And so for my final solution of this, we have just minus 2 cosine e sine x, add a plus c, and that's it. Okay, there you have it, Florida Integration Bee 2017. Thanks everyone for watching. Have a good day.